Okay, thank you, and welcome to everyone also like over there in the call. I know Matthias, you are there, so hello. So we are ending the summer projects. That's sad, but it's also something very good because we have results to show you. And that's what we are going to talk today about the wrap up of the summer projects 2025. So woohoo! Claps. Woohoo! Yeah! That's the energy I like. So great, just tiny recap before we get started. Remember that what's the main goal of the summer projects? So the idea is to give back to the community and promote, the collaborative culture. So that is what summer camp is about. And so when we mix that with project, it's to create value while we are learning together, and sharing knowledge between us. And that's the main goal of the summer projects. Then the result, of course, because we really believe that if this happens, only amazing stuff will, be the output of this. So at the beginning of the year, we asked to the community, hey, what should we work on this year? And we have 12 proposals this year, and that was amazing. A lot of great ideas. And of course, we presented that to you. And again, we asked to you again to tell us what ideas you think are more valuable to the community. And of course, what ideas are you willing to work on? Because if not, we are not going to get anywhere. And you said, okay, let's work on David Hassun's project, the VAST to server-guided insertion, woohoo! And Mike's project about creating a medieval quick player. And those are, the technical sponsor this year. Claps for you. And thank you. Thank you for the proposals. We worked for 3 months on those projects. We started like in November, something like that, with both projects. And we're here in the summer week, and this is the demo and the ending. But we really have so much fun. Some script caps I got from just taking mate, talking, of course, Big Bang Bunny. And today we want to show you some of the fun we have and also the results we achieve. So let's start with, again, Javi. Oh!
Vamos, pero quedan un par de más.
Okay, so let me give you just, we have to just tie everything right now, so some gaps will happen and issues, but don't worry. Short intro about what also David just told us in the lightning talk. What is about the VAST to server-guided ad insertion project? So remember, first we have a VAST. What is VAST? VAST is basically an XML standard for signaling ad videos. So most of the ad servers will, if you ask, hey, give me an ad, it will respond a VAST XML. Also, it has support for tracking events to know, hey, I'm playing this ad, now I'm in the middle of the ad, and whatever, because it's very important to know if we can get the money. And it's very used for, server-side ad insertion, client-side ad insertion that we just saw also with David. And in the other hand of this amazing world, we have, for example, HLS interstitials. That is something that makes it easy to create and deliver features like, mid-rolls and stuff like that. In this example, we have an M3U8 file, a playlist in HLS. And we are going to have here something that is called interstitial, and it will point to some asset list, as you can see. It's a JSON, some URL that will respond to JSON. That JSON will bring inside multiple videos that you should play. In this example, the files that are like in this part of the video, those segments are going to be replaced by the content that this URL will give you. So from that idea, that was David said, hey, let's create a server-guided, a converter from VAST to server-guided insertion, so we can give to the community something to adopt very quickly this new technology, let's say. That's what the project was about. So yes, and let's start from the first challenge now.
Yes, now it's my turn. All right, so well, we started thinking about what do we imagine the service to be, and what are we going to build. So we knew we wanted a proxy between the player and the ad server, something that's in the middle, then that provides everything the player needs to play the ads using server-guided insertion. That's also decoupled and packager agnostic. And also we wanted it to be a microservice that's stateless and can scale with the user views. And also we are just using BAST, not BMAP. BMAP basically tells where the ads are going to be, and BAST contains the ads. So our work is on the BAST file, not on the BMAP. That's other part of the work. So to test all our work, we needed something. We needed a player, something that's not an iPhone player that supports HLS interstitials. And for that, we have HLS.js, that's a player for JavaScript, that on October 10th, here you can see it, it released a version that that supports interstitials. That's great. So the project actually started on November 11. That's my birthday, so I remember for that. And it was a month before we started the project. So this stuff make me wonder where would be if it wasn't because of the community. So thanks to Rob for starting this. It's an awesome project. Well, with all this information that Nico shared with us and the little we knew about this, we created this small diagram with not so much information on it. But first, we knew that we have a packager that creates the manifest adds the interstitials to it. We knew it will call to our service somewhere, and that's it. We didn't know much about it. And then the player that asked for that manifest to a CDN, and with that manifest, the player will be able to call our service and the service will communicate with the ad server. That's why it's a proxy. It's in the middle of the player and the ad server. And the ad server will return as a BAST, which will be transformed by our proxy, and return an asset list to the player so the player can reproduce the interstitials. Okay, enough with the intro. We needed to generate an asset list from the BAST. How can we do that? Okay, so Nico shared with us how a BAST file looks like. It's an XML with all the ads that can be there. So a BAST file can contain a single ad, that's just an ad there, but it also can contain an ad pod, that's a group of ads that can be played, that have to be played in a certain order. Also, it can have an ad buffet that the player selects the ad that it needs to play in whatever order. It's a simple explanation of how it works, a little bit more complex, but it serves as an introduction. And we needed to transform all this to the HLS asset list, so the HLS player can understand how to reproduce the interstitial. So that's a JSON object with a list of assets, the URL, and the duration. That's it. We get the ads from the BAST file and return this JSON. Okay, so something important to mention is that the BAST files can contain different ads in different formats. It can be MP4, M3U8, whatever. But should we transcode those videos to reproduce it in our HLS? It wasn't worth it. We didn't have the time to do that, nor was the purpose of this project to learn how to do that. So we took it out of the scope. We are just working with BAST files that have HLS content.
Woo! That comes next. Spoiler.
No problem. And again, we found in the community a library to transform those BAST files into something we can use to create the JSON. So this library by Dailymotion was super useful to give them a bust file, the XML, and get a JavaScript object with all the information about the bust. There we could take the ads. So again, thanks to the community, it was super helpful. And Nico found a bug there while he was testing the library. He was able to fix it. He created a pull request. He was approved. And today, when I was coming my bus to the office, it was a pull request was merged, and we have a new version with this fix. So it's always great to give back to the community. It's like saying, hey, your library was super good. It was super helpful. Thank you very much. And here's a small improvement. So kudos, Nico, for that. Well, enough with the boring stuff. We need to define an API, how it's going to work. So something that we know about ads, David mentioned it, and we need the ads to be personalized. That's the main idea of this. And how can we achieve this using the same manifest? How can we personalize ads if we create just one manifest for all of them? That's where the HLS query params came to our lives. This definition helps parameterize the different variables that then can be used in the playlists. So, for example, when we request our M3U8, a manifest, we can set different query parameters that then in the playlist can be used, have to be defined as shown in the first lines of code. And then these can be used like when asking for the asset list. But also we tested out, for example, in the duration to parameterize that, and it worked. So it was a good finding. So it was really helpful to send extra information to the app server to get this personalization. Okay, another thing about the service we created is that we defined some environment configuration variables. We wanted to highlight 3 of them, at least, that we think it's worthy to comment on. First of all, we have the bust whitelist. That's, well, the allowed domains where to get the bust files. Then we have the origin whitelist. That's who can request to our server, to our service. And then we have the bus mapping JSON. That's something you will understand a little bit more in the next slide. But basically, it's an object with an ID and a bust URL. Okay. So next, we defined the query parameters. We needed to tell the API where to get the bust file from to process it and parse it and return it to us. So we defined 3 different methods. First of all, we have the JWT. That it's a token where you specify the URL for the bust file. Also, you can sign it to be a little bit more secure. Then you can set a bust URL. This bust URL hard-coded. It's simple as that. And then we have the bust ID. That's, as I mentioned earlier, you can set the ID of the bust file that you define in the bust mapping JSON. And we think this is a good opportunity because when the packager creates the manifest, you can set a bust ID instead of a hard-coded URL. And it will be really helpful because if you have to change the bust file for certain content, you won't have to repackage again. It's just changing the configuration file in the proxy, and that's it. And then every extra query parameter will be passed through to the ad server, like to get the personalized ads. Okay, so this is an example on how to use it. When we have the playlist and define the interstitial in the date range tag, we have the asset list. That's all that I mentioned earlier. It's the URL to get the asset list from, the JSON. And here we call our service. Then we set the query param, that's the bust URL in this case, the URL to get the XML, and then any other query param you want to pass through to the ad server. In the first case, we have the bust URL, and in the second example, we have the bust ID. It's just as simple as that. And now that we have more information, we understand a little bit more how this works, we were able to complete the diagram I showed you earlier. Well, first of all, imagine we have the packager that adds the call to our bust server service, to the bust to server guide insertion service in the manifest. It's stored somewhere, distributed by a CDN. Our player will get the manifest from there, and also we request the asset lists. And for that, it will define, well, the query parameters we talked earlier, and the other extra query parameters. The service will call the alt server. The alt server will return a bust file. We will transform it to a JSON asset list and give it back to the player so it can reproduce the interstitials. And now we are going to show you a small demo of that. So, like that. Perfect. OK, I'll reload. So, well, when the player starts, we are going to get the manifest. Here, it's the first playlist. And here, we have the asset list. This will call our API with the bust URL and some other query parameters. And when getting the asset list, it calls our API. That's the same domain. And as a response, we have all the two ads that are shown in this bust file. Don't look at the other parameters. I will discuss them in another slide. But here we have the assets, the URL for the first ad, and the duration, and the same for the second one. Okay. Let me show you how this works. So when I press play, the 5 seconds or so, it will start with the ad. I know it says pre-roll, and it's not a pre-roll, but we just needed an example, and Google gave it to us as a pre-roll. So that was basically it. So going back to the presentation. There. We wanted to go a step further because, you know, the whole purpose of ads is getting money, and we won't get money if no one sees the ads, or at least if we don't know they have seen it. So bus files contains different tracking events. For example, the start, the first quartile, the midpoint, the third quartile. That's when the user gets to a point in the playback that corresponds to one of those events. A request is sent to the server to say, hey, the user watched this ad, or at least until this point. To transform this into something HLS and Dash understands, there's a SBTA documentation that tells you how to do it. So this is still a draft, and we worked based on this, so it might change. So, but again, thanks to the community for this. It's so important, and it made our lives a little bit easier to get this information. And in this document, we can see that there are 3 types of events. First, we have the impression. It's like the ad was displayed, that's it, send an impression. That's the whole purpose of it, if it was able to be displayed. Then we have the quartile. Is if the user got to a certain point in the playback, send the tracking event. And then we have the click-through. That's basically when there's a place when the ad is interactive and the user clicked on that, send the information. So this is the whole parts of it, where we have the ad creative signaling that you saw on the demo, but it was a spoiler. we have the first quartile, for example, is start 0, so this corresponds to the start tracking event, and then it continues with other. So, okay, so something we knew is that we needed to map the bust tracking events to the activity signaling. For that, impression mapped to impression. That's super cool. Okay, super easy. But then we had the start, the first quartile, the midpoint, all of them. Those all correspond to quartiles in the activity signaling. So it was rather easy.
And we know that just changed in the next draft, but
okay, we know well.
But doesn't matter.
As I say, it's a draft, and we base on the previous version, so it is not updated. But okay, we're super cool. We mapped all the tracking events. That's good, but the one that has to make the work to make the request and track those events, it's the player. So for that, we had to implement a plugin for HLSIS that reads the interstitials, understands that where the tracking events are, and compare the playback to see what events to send. So we created this simple plugin, and it's super easy to instantiate and use it. So it's just 2 lines of code. So I'll do another demo. So I'll reload. It's the same bus, the same API, everything, but this one has this player instantiated the plugin we developed. So this is the plugin, and this is the asset list. Now I'll get more into the activity signaling. In this case, the bus file contains multiple quartiles and an impression. So you will see the one at the start, in the middle, and in the end, and also the impression. So I will start playing, and when the ad starts playing as well, it will start sending all this information. As you can see, the start, progress at 1 second. This is the impression, first quartile, midpoint, and so on. And when the other ad starts, the same, it has its own events. So that's it. We can go back to the presentation. Thank you very much. And then, okay, there's another thing that can be monetized in these bust files, and that the clicks, when the user clicks on interactive pop-ups or whatever. So bus definition contains the video clicks, the click-through, that's where to take the user from when it clicks the pop-up, and then where to track that the click happened. So when we transform this, based on the specification of SBTA, this is not something official, but we kind of created our own. So we have the definition of the click-through and the click tracking. So here we had to create another plugin for this to make it work. We made it to show the pop-up, a small pop-up, and also if you click it, it will track the event. So let's go to the final demo, I promise. Perfect. And I just want to show you that the asset list for the first one, it contains a click-through, and it will track to two different URLs, and the other one has just one. Okay, so I'll start playing. This is the pop-up, and if I click it, it will redirect to that, but it will also track that the user clicked on it. And the same for the second one. If I click, it will track the other one. So now we can go back. And now I can leave you with the final part of the presentation.
And so off. So great, we almost replaced Bast. And we thought about, hey, what happened with mpeg dash? Because great, but what if I'm using mpeg dash? And maybe you know, right now, there is a lot of work being done by Alex Gilari to try to have interstitials in mpeg dash. So the idea is we are going to have what is called alternative MPDs, and you can see here that in an MPD we are going to have an event that starts at some time, and then we can define a replace, for example, a replace presentation with a URL for an MPD. And another thing that it's added in the new Dash 6th edition is what it's called list MPD. List MPD is a type of MPD. It's not the static or dynamic MPD that maybe we are most used to. It's just an MPD that can have different periods, and each period has an import MPD. An import MPD, it's a URL to another MPD. So basically, this is like, you know, the way interstitials are mentioned in HLS, and instead of sending JSON, we're sending a XML to represent the asset list, because it's almost the same. We have the same information: URL, duration, same information we had in the JSON. And so for that, and another demo. Come on, you can do it. And we call it this like the demo of the drafts, the draft demos. We have, this is a Dash.js with an early implementation of alternative MPD working with live content, replacing content from the, maybe you can open the MPD, first MPD. Yeah. So, filter MPD.
Yes,
Filter MPD, great. So the first one, here we have the alternative MPDs. Then we are having here the URL that the MPD we are pointing to is the list MPD of our API that it's going to ask for Google. It will return the list MPD. So we can see each list MPD here. For example, that one. That's a list MPD, which has one imported MPD. That's the Google pre-roll that right now is not a pre-roll. That doesn't matter. And it's working. And that's great, because we are almost there to have this into production. And as the cherry on the top, you can see that we are sending also information through CMCD version 2. So also, if you filter here, for example, event mode, just event, you will see and open some of those. This could be another demo. Payload being sent every X amount of time, or each time the player enters to the interstitial event, like, hey, I'm entering interstitial, I'm ending an interstitial. So that's why I call this like the Frankenstein of the demos, because everything is like in draft versions, but it's kind of working. And I think it's great because we are taking just a sneak peek of what the future of interstitials will look like if we also add CMCD and all this stuff. So it's, for me, it's super exciting. So claps for that, for all the work in here. I want a special shout out to Matthias, that I know you're there. He has a very great project you have to check out. It's called SuperStreamer. This is the URL. It's an open source project that you can find that also has a stitcher, a player, packager, everything. That's super cool. You should try it out. And he has done a lot of work with this. He joined all the calls, and while we were implementing our service, he was also like learning with Dash, implementing his project. So it was super amazing. So thank you, Matthias, for joining this. And I don't know, maybe we can show it at the end. We have also today Ian over there. he just created a plugin in WoW's streaming engine for live content that works with the service. So we are going to be able, you have it there? You can show it? Why not? Why not? Because this is just like brand new, really. It was like 1 hour before we started this, so it was not planned. And I think that's the great thing about also like the summer projects.
Just me.
Let's check it out. An interstitial event is added, and yep, pre-roll over there. It's not the pre-roll again, but interstitial being played out. So this is great. Because again, I think the great thing about this is that Ian was able to, I don't know, how many times, how hard was it to add it?
All night.
Perfect. But it's done, so great. Thank you for that, Ian. Here are the repos, also the QR for the recording, or if you want to take a picture, awesome. And we have a live demo with all the things you saw are running on the demo. We publish on Qualabs, and that's great. If you want to check out, and if you want to put this into production, it will be great. So just tell us. So thank you, a big claps for everyone who worked on this project, and that was awesome. And thank you, David,